Okay, so turn to acceleration in your workbook. And this unit is basically for people who will need to take physics in college. You will see acceleration. They'll get into it more detailed than I will, but at least you'll know kind of what the formula is, that it's a rate, you know, what's involved, what the coefficients mean, but we're just going to get into a very shallow understanding of it. Okay, so here we are. Okay, turn to this page. And acceleration is defined at the rate of change of velocity. It is how quickly an object's velocity changes. So it's a rate. It's a rate of change of velocity. Okay. Now remember, speed and velocity are pretty much the same thing. One's the scalar version, one's the vector version. They're both measured in meters per second, right? Well, this is going to be your first formula where we actually have a third kind of unit involved. So we have in our numerator, as you can see from the formula, acceleration, and because it has a hat on it, what does it need also? A direction, good. It is velocity over time, okay? So you're gonna have velocity units, which is like a meters per second, kilometers per hour, and then you're gonna have another time measurement on the bottom, okay? So we'll talk about what that means. So first off, here's the formula. Velocity 2 minus velocity 1 all over time 2 minus time 1. What does that even mean? Okay, let's talk about that. Okay, in order to figure out if you accelerated, y'all, the slang version of accelerated is, did you accelerate? Did you speed up? Okay, when you slow down, it's called deceleration. Okay, so all they're asking you is, did your speed change? Okay, so in order to find out if your speed changed, you have to have a first speed and a second speed to compare it to. Okay, so all that means is you take your second velocity or speed minus your first velocity or speed. You divide that by your second time and your first time, okay? Or if we want to put all this together, it would say acceleration is your change in velocity all over the change in time, okay? So keep in mind, you're gonna need 2 points, okay? Okay, you're gonna need point 1, which we need to know, okay, what was the speed at that point? I'm sorry, the velocity at that point, and what was the time at that point, okay? So we have our first point, and then we need a second point to compare it to, and we need a velocity at that point and a time at that point, okay? Now, when I was in college, and it all is subjective to your professor, I liked to call it initial velocity and final velocity. So remember, the word initial means the first, final would be the second, okay? So in order to get an acceleration, we have to compare 2 points, okay? Okay, so the next thing they wanted to point out is, why are the units gonna be so weird? We've never seen units like this before. Well, let me tell you why. Okay, so acceleration, the formula, like we just read, is the change in velocity all over the change in time. So the units for velocity, for example, are meters per second. All over the units for time would be like seconds. Okay? So in physics, acceleration is in meters per second per second. That don't look right, okay? So what we can do based on math properties, we can say, okay, we're gonna take this right here and say meters per second. If you divide it by seconds, you could actually multiply it by the reciprocal, correct? Yep. So I'm gonna multiply it by the reciprocal, which is 1/seconds. And that's how I get meters per second times seconds, seconds squared, okay? So the units for acceleration are either meters per second or meters per second squared, or like kilometers per hour squared, kilometers per hour, okay? Okay, so let's move on. The last thing I'll talk about very briefly is if you had to, so when we talk about acceleration, we're actually going to get positive and negative coefficients, okay? If you accelerate a positive 1 meters per second, you are going faster, you're accelerating. If you accelerate negative 1 meters per second, negative 1, you're slowing down, you're decelerating, okay? So positive signs and negative signs tell you about acceleration. Also, if you would have to add them to a coordinate plane, there's some rules too. I don't do this, but just so y'all know, here's some rules. So first off, the units of acceleration may look odd at first. Meters per second squared, fill that in. This is a shorter way of writing meters per second. Acceleration is the rate of change of velocity, how much the velocity meters per second changes every second. Okay. Acceleration takes its direction from the change in velocity. Since the initial velocity and the final velocity could be in different directions, it is important to define which direction is the positive direction. Forward is typically positive and backwards is typically negative. Using a compass, typically north and east are positive directions and south and west are negative directions. You do not need to always use this convention, but for some problems it would be logical to set south or west to be positive. Okay, I don't use this, but like I said, I'll mention it because they did. So what they're saying is you always need to denote positive and negative directions. Okay, but my hint to you is whenever you're doing acceleration, you go to the last point that your final point, and whatever direction you're going in, that final point is the direction you're going in. So your direction, despite anything like this, is the final direction. So whatever your final direction is, that is your direction for your acceleration. Okay? Okay. So they started us out with a doozy, and I did not love it. Okay? So I am instead going to start off with example 2 and come back to example 1. Okay. A hockey puck with initial velocity of 65 kilometers per hour west ricochets off the boards. After 0.76 seconds in contact with the boards, its final velocity is 47 kilometers per hour east. Determine the acceleration. Okay, so I wanted you to do your first problem where we can just plug in all the numbers and we get our acceleration, okay? So they are asking for the acceleration, okay? First thing we're gonna do is write our formula. Acceleration is the final velocity minus the initial velocity all over the final time minus the initial time. So that means what I should do to keep all my numbers straight is to list all of the variables down this side and basically say, okay, which one am I missing? And that's how I'm gonna plug it all in. So ready? I need to figure out my A, so I do not know my acceleration. And then I wanna list my velocities and time. So how do I do this? So this is how I do it to keep my numbers straight. I say the first number you should always get is your initial point, okay? So I always say put your velocity 1 first, time 1, so our first point, then our velocity 2, and our time 2, okay? Now let's reread our question and fill in what we know. Now the first thing I am gonna do with this question, just because I wanna simplify it, is I do not want to do conversions. I want to change something in here so that we don't have conversions. So ready? Kilometers per hour, seconds. Y'all, I know this is a little bit lazy, but I want you to change that seconds to H hours. It might make the answer a little bit silly, you know, but I want to just plug it in and teach y'all how to plug it all in. So ready? A hockey puck with initial velocity, boom, it tells us our initial velocity. Remember, the word initial means first. So our first velocity, V1, is 65 kilometers per hour west. It ricochets off the boards after 0.76 hours. Well, hey, they didn't give us an initial time. If they don't give you initial time, what should you always fill your time in as? 0, perfect. So 0 hours is our initial time. So if they say something like after 0.76 second, or after 0.76 hours, they're assuming the initial time was 0, so after 0.76, this is what happened. Good job, Ryan. Okay, so after 0.76 hours, we have 0.76 hours. In contact with the boards, its final velocity is 47 kilometers per hour east. Okay, now after reading that question, what was the final direction of the puck? East. So it is going to maintain that eastward acceleration. So that is the direction we're gonna pick, okay? So let's sub into this formula and get an answer. So ready? My final velocity, I'm going down here, is 47 kilometers per hour minus my initial velocity, 65 kilometers per hour, okay? All over my final time, 0.76 hours minus my initial time, 0 hours, okay? So all I did was sub in. Okay. So my acceleration equals, can somebody tell me what 47 minus 65 is? 18, okay. All over, oops, sorry, kilometers per hour. All over, well, 0.76 minus 0, that's just 0.76. 0.76 hours, okay? When you do that on the calculator, what do you get? Negative, it's like 20 something. Negative 23.7, okay? Units, kilometers per hour, or kilometers per hour squared, and it's in the direction of east. Okay, so all we had to do is just make sure we had our formula, listed out all of our variables, plugged it in, and just did the math. Okay, so let's talk about what's important here. We have a negative sign. So remember, when you're positively accelerating, you're speeding up. When you're negatively accelerating, you're slowing down. What happens when it says 0 acceleration? not stopped. If you're not accelerating, you're doing what? Constant. Good. So 0 acceleration does not mean you're going 0 miles per hour. It means you're just not speeding up or slowing down. You're maintaining your own cruise control, okay? Okay, so now let's go back up to question number 1. Okay. A horse begins a race from rest with an acceleration of 2.2 meters per second squared north. What is the horse's velocity after 5.8 seconds? So what are they asking us for? Initial velocity or final velocity? They're asking for our starting velocity after 5.8 seconds? So what is the horse's velocity? Well, are they asking for V2 or V1? What is the horse's velocity after 5.8 seconds? What are they asking us for? V2. Okay, good. Okay, so we have acceleration equals velocity 2 minus velocity 1 all over T2 minus T1. And then we got our acceleration. V hat 1, V hat T1, V hat 2, T2. Okay, there are 2 ways to do this. Let's sub in first. Okay, so a horse begins a race from rest. So if you're at rest, your speed, your velocity is 0, and they're using the units of meters per second, and your time is 0 seconds, okay? So whenever something says at rest, it's 0, 0, okay? What is the horse's velocity? So this V2 is our X after 5.8 seconds. Okay, so there's 2 ways to do this. I like subbing everything in and then trying to solve for that one number, but a lot of people say, hey, before you sub in for any numbers, just manipulate the formula to where you're solving for what you need. So guys, if we are solving for V2, right here, V2, let's just manipulate the formula to where we have V2 equals. Okay, let's try it. Okay. How do we get V2 by itself? First off, okay, I'm gonna make it a little bit bigger over here. A hat equals V hat 2 minus V hat 1 all over T2 minus T1. Okay, how do we get, what is the first step you would take to try to get this by itself? We have to get it by itself. What do we want to get rid of first? Do we want to try to get rid of the times? Do we want to try to get rid of the velocities? Come on. Okay, first thing I would do is I would get rid of the times, okay? How do you get rid of times on this side? You multiply it, okay? So I'll multiply this side by T2 minus T1. Multiply this side by T2 minus T1, okay? This crosses it out, okay? This side is, doesn't matter how you write it, acceleration. Oh, my bad, I forgot also here, we forgot to put acceleration up here. It says it starts race with acceleration of 2.2 meters per second squared north. Okay, So we have acceleration multiplied by t2 minus t1 equals v squared, v2 minus v1. Now how do we get v2 by itself? So we have to get rid of v1. How are we going to get rid of v1?
Subtract v2 to the other side, or divide it.
Nope, we don't divide. So, it's okay. I didn't know if you saw this or not. Honors kids, McLean, Coben, y'all never kind of saw this before. If I am subtracting v1 on this side,
You add it right on both sides?
exactly. So I want to add plus v1 over here plus v hat 1. That gets rid of that there. So guys, if you wanted to solve for v2, you just put it by itself, and now it becomes acceleration t2 minus t1 plus v1. Now, I do not like doing it like this. I like subbing in all of my numbers and then doing the math. Did you guys like doing this with the formula? No, it was very complicated. But just so you know, you could take anything, even the Pythagorean theorem, and I know for the Pythagorean theorem, it's a squared minus b squared equals c squared. So you're solving for c squared, but at any time you can solve for a squared or b squared, okay? Okay. Let's move on. Did we do this one? A child rides a bicycle from rest? Nope. Okay. Acceleration equals velocity 2 minus velocity 1 all over time 2 minus time 1. What is my acceleration? What is my v2? T2. v1, t1. Okay, a child rides a bicycle from rest. What did we just say about rest was? 0. When you're at rest, your velocity is 0 meters per second, and your time. Oh, y'all, sorry, I did it backwards. I want to do velocity initial first, then time initial, then velocity final, then time final. Okay. At rest means you're starting at 0. So your initial speed is 0 meters per second and your initial time is 0 seconds. Reaching a velocity of, okay, so if you reach a velocity, that means that you get to it. It's your second point, 3.8 meters per second after 4.7 seconds. What is the acceleration? Y'all, we just plug in. It's easy peasy. Our second velocity is 3.8 meters per second. Our initial velocity is 0 meters per second. Sorry. Our final time is 4.7 seconds minus our initial time is 0 seconds. 3.8 minus 0 is just 3.8 meters per second all over 4.7 seconds. A hat equals, when I do this, .8 divided by 4.7 equals 0.81 meters per second squared. Ooh, we forgot directions. Ooh. So when you were at rest in the beginning, it didn't give us a direction, but it did tell us that our velocity was 3.8 meters per second east. So whatever that final velocity is, That's what this is gonna be too. Okay. Is it easy when you get all the numbers? I agree. Okay. Okay, let's go to question number 2. So we did a child. Okay, we're doing the limousine. This will be our last question for the day. Okay. A limousine driver notices a stop sign while driving 55 kilometers per hour. What is the acceleration of the limousine if it comes to a complete stop in 4.3 seconds? Sounds like he slammed on his brakes. Okay, interpret the sign. What does it mean? We talk about this all the time, that's fine. Okay, so ready? Acceleration is final velocity minus initial velocity over final time minus initial time. Okay, what are all my V1, T1, V2, T2. Okay, so there are all my unknowns. Let's fill them in. A limousine driver notices a stop sign while traveling at 55 kilometers per hour. So what is 55 kilometers per hour? V1, good. So it's our initial velocity. We are going 55 kilometers per hour. 55 kilometers per hour. What is the acceleration of the limousine if it comes to a complete stop in 4.3 seconds? So guys, first off, it didn't tell us an initial time, so we're just gonna fill it in as 0 hours, okay? Complete stop, what is that velocity? 0 kilometers per hour. And where it says 4.3 seconds, time 2, 4.3 seconds. Okay, yes.
Would it be negative or stopping?
We will know that when we sub it in. Good question. Okay. So first off, we do have to do a conversion. I'll do one conversion with y'all just so y'all can practice, okay? So I'm just gonna put it up here and we'll box it off, okay? So because we have kilometers per hour, 0 hours, let's convert seconds to hours so we can plug it in, okay? So 4.3 seconds over 1. All I need to do to convert this into hours is do the conversions, which is like 60 seconds is a minute, 60 minutes is an hour, okay? So 60 seconds are in 1 minute. And 60 minutes are in 1 hour. I know some of y'all look at this and you're like, oh my God, I can't do, this is a lot of math and we're trying to do science. This is why I don't want to do too much conversions, but if you had to do it, okay, here's our conversion. So really, and we knew our number is going to be very low because we're going from only 4.3 seconds into an hour, so we know it's going to get pretty little. 4.3 divided by 60 divided by 60. Okay, so our conversion, the number that we're going to use is 0.0012. We're out of seconds, out of minutes, and we're just left with hours. Okay, so I'm just going to box that up. So right here, instead of 4.3 seconds, I'm gonna convert it 0.0012 hours. Okay, so now let's just sub it in. Acceleration equals final, which is 0 kilometers per hour, minus initial, which was 55 kilometers per hour, all over final time, which was 0.0012 hours, minus initial, which was 0 hours. So our acceleration equals, and just like Naomi said, well, hey, can we put in the minus sign already? It's even if we keep all of our variables positive, our math will give us the correct signs. So ready? 0 minus 55 is negative 55 kilometers per hour, all over 0.0012 minus 0 is just 0.0012 hours. So our acceleration equals negative 55 divided by 0.0012 equals negative 45,800, sorry, 0.33, 45,833.33 kilometers per hour squared okay. Did they give us a direction? Ever? So this is when we would go back to that first page, and if your professor denoted negatives and positives, you would, based on what they initially denoted, saying, okay, my coefficient's negative, and we're talking about these, it's either gonna be west or south, okay? So west or south, okay? Okay, y'all, we'll do a little mini lab tomorrow, just playing with our marble experiments, getting some velocities or accelerations. Whew.